Alright, so we've replaced all of the out of tolerance resistors, and so now we've got caps, couplets, resistors. Really the next step that I'm just going to do off camera is I'm going to pull the pot assembly here and take the metal shield off around it and burnish it and paint it, since it has a tendency to get tin whiskers which will migrate inside and cause all sorts of havoc. I'm also going to resolder the rest of the board, and then very carefully with the famous capacitor wizard down here, ohm out all these traces and make sure that we have excellent continuity and everything's ready to go back in. And then hopefully the next video we'll have this wired up to the chassis, and we'll turn it on and hopefully get a full deflection raster out of it, because at that point then we can tackle the IF strip and the tuner and everything else about it. But I like to work backwards on these sets. You get the high voltage and sweep going first, and then you work on the audio, video, IF, and tuner. That's really the only practical way to do these, just because of the way they're built and whatnot. So I'm getting excited. It's about ready to go back in the set, and then we'll power it up and see what happens. So anyways, hope you guys enjoyed this segment of the video. Stay tuned for the next episode. More stuff to come. Hey YouTube, it's JP Dillon. Welcome to part 5 of the 1959 Philco Predicta Princess. I'm finishing up the board here, and I've ohmed out all these traces using the capacitor wizard. The reason why is an ESR meter will far better reveal a dying trace or connection. And it's a good thing I did, because this one down here, that you can see I put the soldered the jumper across, was open. It looked perfectly fine. No visible crack or whatever. But somewhere under this pad there was a break, because there was no continuity through there. So I just put a lead in and soldered it. Touched up all the remaining solders, and it's hard to see on camera, but the blue marks are all the connections that I checked and double checked and everything. You can also see that I've removed the vertical controls, because we need to very carefully paint this housing. And the reason why you do is because this metal is subject to getting tin whiskers. And if that occurs, you'll get all sorts of fancy schmancy sparking and short circuits that are caused by the little whiskers that fray out from the metal. And it's hard to see on camera. If I turn the light on, maybe. But you see the little, I'm looking at the side of there, you see the little shiny, tiny little whiskers there? So they all need to, go away. And so we're going to very carefully take this control apart so that we separate the metal part from the rest of it, and we're going to clean it up and paint it so that we don't have that problem. Because if the tin whiskers show up, it will be just a pain in the ass. Sometimes it can harm the circuit, other times it just makes lots of loud snapping and you see things go wrong while the whiskers are being blown apart by the current going through them. So let's get this thing apart, and the way that you do that is very carefully bend back these tabs, and don't bend them far, because you'll have to bend them back to re-secure it. You bend them too far, they snap off, and then you got to find another way to put it back together. So we're just going to be really careful. And this is what you get when you take the control apart. And you can see that these just kind of come out. The wipers are just really held in by gravity, and it all presses together. So this is really fragile. I don't recommend going nuts on cleaning this unless you absolutely have to. Because if any of these plastic parts break, then you're going to have to get new controls to mount in here and somehow find a way to secure them to the board, because this is the support for this control. But as we can see, now that it's apart, if we can get in here a little bit better, I don't know if you can see all the little shiny whiskers that are in there. they kind of sparkle. It's hard to tell, but you can just wipe the metal away, and then now they're on my finger. You can see the little sparklies on my finger, so we need to definitely, I'm going to clean this with alcohol, and then we're just going to paint it, and once the paint cures, we'll put it back together. Alright, so we've cleaned this up with a lot of Q-tips and alcohol, and now we're just going to rough it up very lightly with some 600 grit, and then spray it. Alright, so she's painted up. We're just going to let this thing dry, and then we'll put it back together. Alright, well there she is back in the board. We're going to solder it up, and then we'll work on getting this back in the chassis, because I think it's done. Again, I've ohmed out all the traces, repaired one additional, checked all the coils and everything to make sure that wasn't open transformers. So this thing's good to go. It's time for it to go back into the set. And there she is, all soldered back up. Now, the reason why I didn't solder both sides is because you don't really need to. All it's doing is grounding the case. And these you're supposed to pinch to be able to get the control out once you've desoldered the actual pots. So this scary looking board, in theory, should work. But it's time to get it back into the main chassis and find out. And this is really the loathsome part of the job, and it's the reason why you marked all these connections. And I did a pretty good job at marking all these connections as to where they go. But still, you almost always run into some kind of snag. So I'm definitely going to need my wits about me and 2 hands, and I can't really put this on the tripod or on the mount because it's just going to get in my way. And I really don't want to make a mistake on this, considering all the time that I've sunk into it thus far. So really, we're just going to put this board in, and then we're going to hook the CRT and stuff up to it, and see if all that effort and work we did is actually meaningful. And if it is, and if we get a raster that fills the screen, or that we can make fill the screen, then we'll worry about the IF strip here, and we'll worry about the tuner and everything else. I thought about doing an AV conversion on this, but looking at the service literature, the amount of data that they want for the first video amp is almost 2 to 2.25 volts peak to peak, which is far above the 1 volt peak to peak that standard composite video puts out. So yeah, I could do that, but the contrast ratio would suck and it wouldn't quite look as good. There are other models that are more forgiving, like 1.5 volt or 1.25 volt peak to peak, and then you could put a 1 volt signal and it looks alright. But this one's just a hair shy of 2 volts, and I don't think that's going to work the way that I want it to. So we're just going to focus on getting the tuner and IF in good working order. And in theory, assuming there's nothing horrifically wrong with the tuner, we should be able to get this thing up and running. So anyway, less yak, more work. Let's get the board in. Okay, so I got everything wired back up here. The board's in. Everything's wired to it. I've added solder to all the wire wraps to reinforce them. Added my own fuse resistor, which is a 10 ohm, 15 watt. Really only needs to be 10, but I had a 15, and then a 1 amp fuse in series. So that should do us for the B+. And now we're going to do a smoke test, put it on the dim bulb tester, and just with horizontal disconnected, of course, we're just going to see if it comes up and if we have halfway correct voltages, and maybe see if we have any action on the vertical, which we did not have before. So let's get to it. Alright, so I got my dim bulb tester hooked up. Let's flip the switch. And that's starting to calm down already, which is good. Filaments are coming up. That's good. Starting to get a little brighter as the B comes up with the tubes warm. Just giving it some time. Yeah, so now we're starting to get a little brighter. So I think things are stabilizing. I don't think we'll see anything, but let me get the scope and see if we can see any vertical action. All right, here's vertical output, but the transformer's unloaded, so let me get a load on the secondary. So that reduces it some. And I can speed up. You can see I can speed it up and slow it down. So the oscillator's running. It's not going to be a clean looking waveform because, quite honestly, this isn't the yoke. It really has to be loaded properly. And also we're running at a reduced voltage, so I don't think it's going to really work all that great for us. I'm just trying to adjust controls and stuff here to see if we can't get a... Yeah, it's linearity. That changes it a little bit. Bear with me a moment. I don't know what that is, but it really doesn't change much. Probably horizontal hold. Alright, stand by. Alright, so this is with the vertical height control adjusted a little better. And you can see it's got a lot better looking waveform. So that's good. That suggests that the oscillator is running. And it should produce an okay picture. It's got a little bit of distortion there, but we're also running at a very reduced voltage. Let's see what our B voltage actually is right now. Yeah, so if we come over here to our 140, our 140 is not too far off, 140 volts down. And then there's like a 275, which is only 150. And then I think there was like another one over here that was like, yeah, that's your 275 line there. So we're significantly down on voltage. I'm kind of curious what will happen here if we just bypass the bulb, and maybe we'll get more vertical deflection. Maybe it'll work a little bit better. And then if we place the top cap on the horizontal, it's not going to start, or it's going to try to start. Yeah, it's not starting. It's just dragging down the B+. Because I'm pretty sure if we come over here and we scope out our horizontal, let's see. Trying to see a good spot. I can grab the oscillator here. Yeah, it's trying. Hold on here. Speed this up so we can all see it a little better. Stand by. Alright, so yeah, it's not really a pretty looking waveform right now, so there's not enough voltage to start it. Why is my B plus varying? That's weird. Didn't like that I had a pressing up against something there. Yeah, no loose tube sockets or nothing. Okay. Let's go back to our vertical and see if we can get a better amplitude here. And I'm not sure why we keep... You see the bulb keeps getting brighter and dimmer. I'm not sure why. Nobody's getting hot. We get a bad connection somewhere. Something happening. Let's see here. It's like freaking out. It's freaking out, man. Make sure I got my alligator clips on here, right? Yeah, I'm just poking around making sure there's no loose connections and we don't need to take this board up again. Alright, let's bypass the bulb and let's see what happens then. Alright, here's the pucker moment. Now see, ooh, she's big. Adjustable? Yep. Alright. A little bit unstable, but it's unloaded, or not properly loaded, so I could see that. But it's working. Alright. So we got vertical sweep, that's good. And I suppose we can check and see if we have a good looking sawtooth on our oscillator now. Doesn't want to sync on that. Not really sawtoothy enough, but that could be, I'm just measuring on the wrong spot. Alright, well, it's running. That's a good sign. Now I think it's time to actually hook a CRT up to it and see what it does then. Just one of those pucker moments. I can definitely smell things like hot resistors and stuff like that, but there's no excess current draw. I think I'm going to go with a 1 amp slow blow instead of a fast blow, because when I energize that, I could definitely see the element of the fuse glowing a little bit, so that's not going to last. So slow blow instead of a fast blow I think will be good. But the surge resistor thing seems to be doing its job. So let's turn this off. Wow, we didn't blow up. Alright, so here's looking at the grid of the horizontal output tube. That's pretty healthy. Nice looking steady wave there. And I'm going to see what the frequency is. Should be around 15,750, I think. I can get my frequency counter going and we can see what that looks like. Alright, so we're going to go right to the test point where my probe's hooked up. 15,733 is pretty damn close. So the horizontal oscillator is working, the vertical oscillator is working. There's a fair chance that when we hook a CRT up to this thing, it's going to be golden, full raster and all. But that's where we're at right now. So let's get a CRT hooked up and see what it looks like. Alright, so we got our chassis all laid out here, and we're going to fire it up. And because it ran without the picture tube and stuff, that at least was our smoke test, or at least I hope it is. But there could be other things wrong. You really don't know until you get a full load on the set. You know what it's supposed to do. So we're going to apply power to this, and we're going to see what happens. And I'm hoping for a full raster given our work. And if we can get that to function, then we can work on going back through the IF and the tuner and getting all that right. And then with any luck, we can put this all together on a bench like this and run it and get an actual picture and sound. So let me get the power hooked up and we'll flip the switch. So here's that pucker moment. It's going to go live. Got the filaments lighting up. That's good. Don't hear anything, don't see anything. Oh, there we go. We have deflection. And we've got roll, so our oscillator's running. Yeah, we got deflection changes there. Alright, so we have something. There's our deflection. Let's see if we can increase the height. Just need to get a screwdriver that'll fit in the slot. We got a little bit of roll there. Bottom isn't coming up too much, is it? So that's odd. So we have vertical. It's obviously rolling. We can stop it. We don't have much on the bottom, do we? And then let's see if we can increase that more. Really not much vertical deflection, is there? So we got scan. We got plenty of brightness. Not sure why we have a lack of deflection. So that's as good as it gets right now. Not quite sure why we don't have that. So we need to check our 10DR7, or excuse me, 6DR7 vertical output tube, make sure that's happy. Because that's a combo oscillator and output. But we have high voltage and we have a raster, which is really good. But definitely still some work to be done. We need to take some voltage measurements and figure out what's going on here. But it's a big start. So I'm really happy with where this is at right now. One thing I notice about this is that the tube is super hot. And it shouldn't be blisteringly hot. It was almost to the point of red plating. Like, I tried to remove it just with like some folded up shop towel and about burned my hand off. So this is definitely something that it concerns me a lot. Alright, so you can see our emission's good on the first section. Let's try the second one. On the second section, it barely registers. Even if we crank it all the way up, it still doesn't register well. So just make sure I got this all right here. Yeah, I do. So it's tired. It's really tired. It's coming up a little bit, but that shouldn't give us a collapsed raster like that. I mean, a weak vertical output tube will give you a little bit of loss, but it won't give you that much loss. All right, so here's our SAMs for the Predicta here. I have the actual service manual too, but this is definitely more legible. So for sure, we need to check and see that we have our bias voltage or proper cathode voltage. So that's going to be pins 2 and 3 for our grid and pin 9 for our cathode. And people were saying that this really relies on the 400 volt supply. You can see there 0.39 right at the height control. That's your boost from your horizontal drive. So we should have 400 volts on the high side of that height control. And we need to check for our 275 at the high side of the vertical transformer, not at the plate of the vertical output tube. That'll injure your meter really good. So we need to check for that, because it seems like it's a low voltage thing. Yeah, the 6DR7 could be tired, but I don't think that degree of tired would yield that loss of deflection. So we need to check our power supply voltages, because that's one thing we really haven't done yet. And it could be the doubler sagging and we're losing our 275, or it could we have a boost problem like a weak dampener, and that could be, you know, contributory to the loss of our 400. So I need to measure at 0.39, and I need to measure at 0.33. And you can see down there that they have a test point for the 400 volt boost supply there. So we need to make sure that's good and we don't have a dying boost filter, because that would definitely piss off our vertical output circuit. And then the, let's see, don't measure at pin 1 for sure. We'd have to measure on the 275 point. There's a test point for that over here somewhere too, I believe. Now, we've got also have a test point over here on the same line. There's a 275 line creeping over here. So we need to check both of those. Alright, so I'm going to go ahead and power up again. And we're going to take our power supply voltages and make sure that we're happy. Because I think there's issues with the boost. Since the vertical relies on the boost, if the boost is low from, you know, tired filters and stuff, that's going to become an issue. See, it starts out pretty high and then it shrinks. We still have our instability here. But anyway, let's check our boost point here. See how low that is? That's supposed to be 400 volts. 400. We got 101.5. So that's really the cause of our loss of vertical. See if there's any hum on it. I'm betting there is. Not a lot of hum, just low. And then let's check our 275 spot, which I think is floating around here. Ooh, tingle, tingle. Yeah, let's not end up in the morgue today. See, 275 is pretty good at 278 there, but our 400's way wrong. So we need to troubleshoot that power supply, which is what I wanted to get through anyways next, because, you know, that's kind of a crucial thing. So our 400 boost is only about 100 volts. That's probably why we don't have vertical, and that may be the cause of a number of other things. Got a little bit of ringing on the left side. Let me get it off the stand here and you can see. we definitely have some ringing, some lack of width, so the boost is definitely an issue. But the chassis is running, so that's good. We're at least mostly there. We were going to get to the power supply next anyways once we validated that it ran, so this is good. So that's all for this episode. Stay tuned to the next one. We'll deal with the power supply issues, get the power supply recapped, and then retest it. And very likely, this will come back to life. And once we get that full raster that we're looking for, then we can work on getting the IF and the tuner dialed in. But so far, so good. I'm happy this is where it's at right now. Better than it was. So anyways, thanks for watching, guys. More stuff to come.